Today we are going to cover Chapter 9, Lesson 2. It is the matrix solutions of a linear system. So on this first slide here, this is some of the transformations that you can perform on the different rows of your matrix. You can interchange any two rows. You can multiply or divide the elements of a row. You can also multiply and then add to get a new row. The method that we're going to be using is this Gauss-Jordan. However, the name isn't important. Just know that we're going to be turning it into an identity matrix where down the diagonal of our matrix will all be ones. The rest of the matrix, except for our solutions, are going to be zeros. So let's go ahead and try our first example. Now, keep in mind that they're going to get more difficult. Now, notice this system, we could probably solve it using substitution or elimination. However, the whole purpose of these matrices is that when we get to more complex systems, where maybe we have 5 equations and 5 unknowns, then this would going to enable us to solve these matrices with either a calculator or a computer. But for right now, we're just doing these by hand. We're not using our calculators. So the way that we are going to set up our matrix is we're only going to be using the coefficients. So again, remember when you have a variable without a number in front, you're assuming it's got a 1 in front of this x and y. So I'm going to take all of the coefficients. So the 1 that's in front of the x, the 2 in front of the y, the 5, and then the second equation, the 2, the 1, and the -2. So this is how you are going to create your matrix. Again, when you have your system, make sure that it's in this standard form where the x's are on top of each other, your y's, and then your answers or the constant. Now, this is going to separate. You can put this line here, you don't really need to, but know that the 5 and the -2 there on the end, that's the answer or the constant. Now, what we're trying to do here is transform this matrix into an identity matrix. And the identity matrix looks like this, where we're going to have ones down the diagonal. And then over here is going to be the answers for x and y. So our goal is to change this 1, make it become a 1, and it's already there for us, so that step's done. Change this 2 to a 0. Change this 2 over here to a 0, and then this 1 is already done for us. Now, in the more complicated matrices, the 1s aren't going to be already done for us, but we're starting out slow. So part of our matrix is already solved for us. So let's go ahead now and let's see how we're going to accomplish this. Now, whenever we're going to try to change our number to a 1, we're going to divide it by itself. Because what's anything divided by itself? 1. So whenever we're going to try to change a number in our matrix to a 1, we're going to divide or think multiply by the reciprocal. Either way, whenever we're going to change the number from it, whatever number it is, to a 0, we're going to multiply our pivot row and then add it to the row we're changing. And I know I'm saying a lot of stuff. However, as we practice it, it's going to get easier. So we're going to go ahead and start our process. So the order that we need to perform the operations, is we're going down the column. So the first thing we're going to do is make sure that the 1 is taken care of first in the column. And again, our matrix is set up like this. This is column number 1. This could be column number 2. And when I refer to rows, I'm talking this way. This is row 1. This would be row 2. Because I'm going to be showing you when I set it up, my notation for row is R and column will be C. All right, so my goal is to turn this into this. So let's go ahead. The first thing is already done for me. So I'm going to go ahead and now I need to work on changing this 2 and making it become a 0. And the way I'm going to do that is take the row that I just made become the 1, and I'm going to multiply it by -2 and then add it to row 2. So I'm going to multiply row 1. So basically I'm going to distribute a -2 to the row 1. So I get -2, -4, -10. I'm now going to add that to row 2. So I'm going to write row 2 underneath it. Now this is just my work. You can be doing all this calculations in your head if you'd like. You don't need to write this part down. The only thing that's going to be required for me to see is the left side of the paper. So I'm going to go ahead and add this up. This is now going to become, this answer to this addition is going to become my new row 2. So 0, -3, -12. Now, even though I multiplied row 1 by -2, it does not change. It is staying. My new row 2 is now going to be 0, -3, and -12. Now, the next thing I want to change, I've completed the first column. I now need to shift over and I need to change this -3 into a 1. And again, at the beginning, we decided that in order to make something become a 1, we're dividing it by itself. So I'm now going to take row 2 and I'm dividing it by -3. And that will change that 3 that I just boxed into a 1. So 0 divided by -3, -3 divided by -3, and -12 divided by -3. My row 1 is staying the same right now. Only thing I'm changing is row 2, and it becomes 0, 1, and 4. Again, I'm trying to make it look like the identity. I still have one more step. I need to make the 2 become a 0. Again, I'm going to use the pivot row, or the row that I just made the 1. I'm going to multiply that pivot row by -2, and then I'm going to add it to row 1. So I get 0, -2, -8, and now I'm going to add it to row 1, which is 1, 2, and 5. So my new row 1 is going to be 1, 0, -3. This is my new row 1. 1, 0, -3. My row 2 stayed the same. Notice I have it in the identity. The numbers that are over here, this is X, this is Y. You write it as an order pair, -3, 4, and you're done. So 2, we're going to set it up. We're only writing the coefficients. So 2, -3, 10, 2, 2, and 5. Now, notice this one, I didn't have the 1 to start with, so I need to change this 2 and make it become a 1. Because remember, our identity matrix, again, it needs to look like 1, 0, 1, 0, and then the numbers you get here are your X and your Y. So I need to change the 2 and make it a 1, and we've already decided that we divide to make it become the 1. So I'm doing row 1 divided by 2. So 2 divided by 2 negative 3 divided by 2, and 10 divided by 2. So my new row 1 is 1, negative 3 over 2, and 5. I'm going to rewrite my row 2. So now that I've got the 1, I work column down. So now I need to change the 2, and I need to make it become a 0. Again, to transform the number to a 0, we're multiplying the pivot row and adding it. So I'm going to take row 1, I'm going to multiply it by negative 2, and add it to row 2. So my row 1, when I distribute the negative 2 to it, I get negative 2, 3, and negative 10. I'm adding that to row 2, and I get 0, 5, and negative 5. This is now my new row 2. So my row 1 is the same. I've now fixed the 2 and made it a 0. My first column is complete. I now need to move to column 2. I'm working on the 5. I need to make it a 1. We're going to divide row 2 by 5. 0 divided by 5, 5 divided by 5, negative 5 divided by 5. 0, 1, and negative 1. This becomes my new row 2. Let me rewrite row 1. My new row 2 is the 0, the 1, and the negative 1. I still have one more thing to change. I need to make the negative 3 over 2. It needs to become a 0. Remember, when you're making something the 0, you're multiplying and adding. So I'm going to multiply row 2 by 3 over 2. And then I'm going to add it to row 1. So row 2, when I multiply it by 3 over 2, I get 0, 3 over 2, and negative 3 over 2. Row 1, write it underneath, add it up. 1, 0. I need to find a common denominator here. So 3 over 2, I'm going to change the 5 to 10 over 2. So this will give me 7 over 2 when I add that. So now this is my new row 1. 1, 0, 7 over 2. My row 3 is still the same. Or row 2, sorry. My row 2 is the same. Notice I've got the identity on the left. My x value is 7 over 2, and my y value is negative 1. So 7 over 2, comma, negative 1. It's an ordered pair. Now, the next one, I'm going to teach you another matrix transformation. In addition to multiplying and dividing and adding, we can also switch the columns and switch the rows. So this next example, I could technically solve it the same way that I just did the previous two. However, I'd get a bunch of fractions I'd have to work with. So instead of doing that, I'm going to show you the matrix transformation of switching columns and rows. Now, before we begin any problem, it must be written in with the constant on the right side of the equal sign. So I need to move the 10 over and the 15 over. So I need to rearrange this by adding the 10. I'm going to add 10 to both sides. 2x minus 5y equals 10. I need to do the same thing to the second one. Add the 15. 3x plus y equals 15. Now, I've got it in the correct form. Now, I just want to bring something to your attention to why we could change columns. Is remember that if I flip this around, and if I put the y first and the x second, these are both the same thing. The order that you add things doesn't change the answer. Because if I tell you to do 2 plus 3, you get 5. But if I said instead, I want to say 3 first and then 2, I still get a 5. So the order that I write my x and y's doesn't matter. Okay. However, you have to stay consistent. So when I go to put this in my matrix, so if I write this, your x's and y's need to be on top of each other. So I'm going to go ahead and put it in here initially with just the coefficients, 2, negative 5 and 10, 3, 1, and 15. Now, I could solve it like this. However, I see I've got a 1 already in my problem. And I know that I need to get a 1 up here at the top first. So what I'm going to do is I'm going to switch my columns and rows. When you switch the columns, you can only do that before you start the problem. So only at the beginning can you switch the columns. So I'm going to show you how I'm going to switch that. So I'm going to switch and put the negative 5 in the 1 first and the 2 and the 3 second. So I'm switching my columns. Now, you can switch rows anytime. It doesn't have to be at the beginning. It could be at the beginning, could be halfway through the problem. But just remember that if you do that, you shouldn't be undoing any 1s or 0s you've already created. The reason why you would switch rows and columns is to avoid getting fractions all throughout your problem. Now, you could avoid doing this row switch and this column switch, but just know that you might end up with a bunch of fractions in your problem. Now, when we switch these columns, remember that this column originally was for the x's, and this column was originally for the y's. Now that I've switched it, this column is now y, and this column is now x. The same thing is going to occur in my answer here. I need to switch, and now the answer that I get once I get my identity matrix, the y will be first. Now, again, the whole reason why I wanted to move these rows and columns around was to get that 1 up in that top left corner. So now, in addition to switching my columns, I'm also going to switch my rows. Now, this y is attached not to the 10, but it's just attached to the spot. So when I move the row, the x and the y don't go back. They stay. So now, here, I'm going to go ahead and flip it and put it like this. I'm moving my x and I'm moving my row 1 and my row 2. So now this is row 1, this is row 2. When I'm all done, it's still going to be x, y like that. All right, so by not multiplying or dividing or adding or subtracting, I got my 1 up there just by switching rows and columns. So now the next thing I need to work on is changing this negative 5 into a 0. So what we're going to do is take row 1 and we're going to multiply it by 5 and add it to row 2. So row 1 becomes 5, 15, 75. I'm going to add that to row 2, and I'm going to get -5, 2, and 10. That's row 2. I'm going to add it up, and this is now my new R2. So my R1 is the same. I've got a new R2. And now I need to work on the 17. The 17 needs to turn into a 1. Remember, to make ones, we're dividing. So R2 divided by 17. And when I take that, 0 over 17, 17 over 17, 85 over 17. 0, 1, and 5 is the new R2. R1 is the same. 0, 1, 5. My first column is complete. Now I need to shift over to column 2. Notice in column 2, so I was needing to make this 1 become a 1, and it's already done. So now the next thing I need to work on is changing this 3 to a 0. So I'm going to take row 2. I'm going to multiply it by -3 and add it to row 1. Row 2 multiplied by -3 gives me 0, -3, -15. My row 1, let me write it underneath. I'm going to add it. 1, 0, 0 is now my new row 1. And my row 2. And notice I have my identity matrix. And my answer, remember we flipped. So this is Y, this is X. So 5, 0. And again, you could have solved that problem without changing the columns and rows. You just would have had a fraction in your problem. Let me try number 4. Yes?
How would you, because I would have just not done it because there's already one.
Okay, so let me show you how you could have done it without that. So let's say we did the same problem and we didn't change the rows and columns. So again, we're going to put it in as 2, -5, +10, 3, 1, and 15. So for this problem, again, I want to get a 1 in the first spot. So I'm going to divide row 1 by 2. So that'll give me 1, -5 halves, and 5. I'm going to rewrite row 2. And now I need to change the 3 into a 0. So I'm going to multiply row 1 times -3 and add it to row 2. So this will give me -3, 15 over 2, -15. Then I'm adding it to row 2. And then I get 0. This will become, I could change this to 2 over 2. So 17 over 2 and a 0. So now I'm going to rewrite my first row. My second row is now the 0. The 17 over 2 and the 0. I now need to make 17 over 2 become a 1. So now I'm going to take row 2 and I'm going to divide it by 17 over 2, which is really row 2 times 2 over 17. So then this will become 0, this will become a 1, this will become a 0. So my row 1 is the same, 1, negative 5 over 2, 5. Row 2 becomes 0, 1, 0. And now I need to make 5 over 2 become 0. So now I'm going to take row 2, multiply it by 5 over 2, and add it to row 1. So when I multiply row 2 by 5 over 2, I get 0, 5 over 2, and 0. And then I'm going to add it to row 1. And I get 1 and 0 and 5. And now that's my new row 1. And my row 2 is the same. So my identity's done. So my order pair is 5, 0. So these fractions weren't too bad, but because there was a bunch of already 1s and stuff, but it could have been a lot messier. So that's why interchanging the rows would have alleviated all that 17 over 2 and 15 over 2. Okay? You'll still get the same answer. All right, let's try number 4. Again, we're going to take all of the coefficients. So 3, negative 2 and 1, 6, negative 4, and negative 1. And again, I need to make the 3 become a 1. So I'm going to divide row 1 by 3. So then this will give me 3 over 3, 2 over 3, 1 over 3. So 1, negative 2/3, 1/3. And then let me rewrite row 2. The next thing I need to work on is making the 6 become 0. So I'm going to take row 1 and I'm going to multiply it by negative 6 and then add it to row 2. So negative 6, positive 4, negative 2. That's the result of multiplying row 1 by negative 6. Add it to row 2. 0, 0, negative 3. So let me rewrite row 1. My row 2 becomes 0, 0, negative 3. My first column is done. My next thing I need to work on is making this 0 become a 1. Remember, to do that, we were dividing by itself. But 0 divided by 0 is undefined. So when this occurs and you've got a 0 in a 1 spot, the answer is no solution. So if you end up with a 0 in a 1 spot, we can't turn that 0 to a 1, so there's no solution. Now we're going to do the 3 equations with 3 unknowns. We're going to add another column here because we're going to have another unknown. Process is the same, it's just longer. Now, again, remember when we're coming up with our identity matrix, it needs to look like this. 1, 0, 0. 0, 1, 0. 0, 0, 1, and then X, Y, Z, which is going to be over here. So this is our identity matrix of what we're working for. So again, remember, we're trying to achieve or to get a 1 in the first spot. Notice my first coefficient here is negative 1. So before I even put it in, I'm going to multiply this first equation by negative 1. And then it's already set for me. So 1, -2, -6, -2. The other equations are going in as is. 3, 2, 6, 6, 1, 4, -3, 1. Again, we want to change the ones first, and we're doing it column by column, and then we do the zeros. So I've already done the first one in column 1. So now I'm going to work on changing this 3 to a 0. My pivot row, or the row that I'm going to multiply, is always the one that I just changed to a 1. So I'm going to multiply row 1 by -3 and then add it to row 2 to get that 3 to become a 0. So my row 1, after I distribute the -3 to it, becomes -3, +6, +18, +6. I am going to write row 2 underneath it. And this answer that I get when I add is now my new row 2. So my row 1 is staying the same right now. I just got my new row 2. And now I need to fix row 3. That 1 needs to become a 0. I'm still working with the red row 1. So I'm going to actually multiply row 1 by -1 and then add it to row 3. So -1 times row 1 plus row 3. So once I multiply this, I get -1, 2, 6, 2. Adding it to row 3. And my row 3 is 1, 4, -3, 1. So my new row 3, which is here, is 0, 6, 3, 3. Yes?
Why did you pick row 1 to multiply again?
Because that's my pivot row. That's the one that I changed to a 1.
Oh.
So
we
what-
have to do that for like all of them, we have to multiply by 1 for at least one of them?
You always have to change one number in that column to a 1, and that's the one that you'll multiply to change the other 2. Yes?
So for each column, you're gonna have to multiply by the first one, or just the one that has the row that has the 1 in it?
The row that has the 1 in it is what you're going to multiply it by, and then add it to the other one to make it the 0. All right, so now we're moving to row 2. Now, when we did the other ones where we only had 2 columns, I went to the bottom first. But I'm going to the one where I want to change it to a 1. So see in my identity matrix up here, this is the one I'm going to change first, the 8, because that's the one that needs to become the 1. So I'm going to divide it by itself first, change that 1 to the 1 first, then I can change the -2 and the 6. So I'm going to take row 2, and I'm dividing it by 8. So I'm doing 0 divided by 8, 8 divided by 8, 24 divided by 8, and 12 divided by 8. So I'm changing that row. I'm going to go ahead and rewrite the whole thing just so we can see what's going on here. So then my new row 2 is 0, 1, 3. 12 over 8, I can reduce that and make that 3 over 2. You fill in the green. All right, now I need to make the -2 become a 0. And I also need to make the 6 become a 0. So I'm going to do the -2 first. So again, the row that I just made become the 1, which is row 2, That's what I'm multiplying. So I'm going to take row 2, and I'm multiplying row 2 by positive 2, and then adding it to row 1. So row 2, when I multiply it by 2, I get 0, 2, 6, and 3. My row 1 was 1, -2, -6, -2. So this is now my new row 1, 1, 0, 0, 1. This is my new row 1. My row 2 was good. I can fill that in. And now I need to fix row 3. I need to change the 6 to a 0. I'm still working with row 2 because I'm still in column 2 there. So I'm going to multiply row 2 by -6 and add it to row 3. So row 2, when I multiply it by -6, is going to give me 0, -6, -18, and -9. I'm adding it to row 3. And I get 0, 0, -15, and -6. This is now my new row 3. My second column is complete. Now I need to move to column 3. Again, I want the identity matrix up here. So now the thing I need to change is this one right here. And I need to make that 15, -15, become a 1. So I'm going to take row 3 and divide it by -15. 0 divided by -15, 0 divided by -15, -15 divided by -15, and -6 divided by -15. So my first row is still the same. My second row is the same, but I have a new third row, 0, 0, 1, and the 6 over 15 can simplify. I can reduce it and divide them both by 3. And this will become 2/5. Now I need to go back up and I need to change one more thing. I already got a red 0 up there, but I need to change this one also to a 0. So again, I'm using the row I just made a 1, so I'm using row 3. So row 3, I'm going to multiply that by -3 and add it to row 2. So row 3 multiplied by -3 is going to give me 0, 0, -3, -6/5. I'm adding it to row 2. That's going to give me my new R2, 0, 1, 0. And I don't think I was videoing.